Hello everyone, this video is about accuracy, precision and uncertainty. Let's learn about these very important concepts in physics and stay tuned until the end for a practical example. Let's start with accuracy. Well, accuracy is how close a measurement is to the correct value for that measurement. Let's take a look into an example here. So let's imagine this object here that has a real length of 17 centimeters, okay? Then we take a ruler, our ruler number 1, and measure this length 3 times. And we got these results here. For the first measurement, 17.2, then 17 centimeters and 16.8 centimeters. Alright. Then we take another ruler, a different ruler, ruler number 2, and do the same thing, measure it 3 times. And we got these results here, 17.6, 17.7, and 17.5. Well, we can see that for ruler number 1, the result, the measurement varies 0.2 centimeters close to the real value, okay? It goes from 16.8 and sometimes 17.2, okay? Now for the second ruler, we have that the measurement we took, it's further from the real value, okay? So it's 0.5 centimeters close to the real value. But if you compare both rulers, we see that ruler number 1 is more accurate than ruler number 2. That's because from the measurements we took, it's closer to the real value of the object. So, as a consequence, this ruler number 1 is more accurate than ruler number 2. Now we can talk about precision. Well, precision is how close the agreement is between repeated measurements. Okay, so let's take the same example as before. We have the rulers, our measurements. So we want to know how close is the agreement between the repeated measurements. If you take a look into ruler number 1, we see we had a variation of 0.4 centimeters. So it goes from 16.8 to 17.2. Now ruler number 2 has a variation of 0.2 centimeters. Well, you can see that the variation or the agreement between the measurements, the repeated measurements for ruler number 2 is smaller than for ruler number 1. Therefore, ruler number 2 has a more precise measurement, okay? It's varying less than the ruler number 1. However, ruler number 1 is more accurate because its measurements are closer to the real value. Okay, so ruler number 1, it's more accurate because the results are closer to the real value, and ruler number 2 is more precise because the variation here is smaller than for ruler number 1. Another very important concept to know when you're dealing with measurements in physics is the concept of uncertainty. Uncertainty is how much your measured values deviate from a standard or expected value. Let's use as an example this thermometer here. And this thermometer has an uncertainty of more or less 0.1 degrees Celsius. Well, it means that if you take the measurement here and it's 37 degrees Celsius, for example, the real value can actually be 36.9 or 37.1 degrees Celsius. Now for this another thermometer, we have an uncertainty of more or less 1 degree Celsius. So if we take this measurement here, 82.5, the real value can actually be 81.5 or 83.5 degrees Celsius. This is very important to know because these measuring devices here, these instruments, they have a certain uncertainty, okay? And for example, if you take this thermometer to measure the body temperature, Well, an uncertainty of 0.1 degrees Celsius is actually acceptable, right? If you take your temperature and it's 37.1, it can actually be 37 or 36.9. It's okay, it's not a big difference. But imagine if the uncertainty of this thermometer is 1 degree Celsius, like this one. Well, now it's a problem, right? If you take the measurement and it's 37, it could actually be 36 or 38. Or if you take and it's 38, it could be 37, which would be okay, or 39. So you had like a very strong fever. So for this case, the uncertainty for this measurement needs to be very low, right? Now, if for this thermometer number 2 here, if you're using it to measure the temperature of your steak, for example, your food, this uncertainty is acceptable. It doesn't make much difference if your steak is at 1 or degrees Celsius hotter or 1 degree Celsius colder than the expected, right? So uncertainty is very important for measuring devices. Another important concept to know is about the significant figures. So the significant figures, when you take a measurement, you have a lot of digits, right? The significant figures are the digits that carry meaningful contributions to its measurement resolution. Basically, if you have taken a measurement and the value you got is this one, all these leading zeros here are actually not significant, okay? And the non-digits figures, the non-zero digits, they are significant figures, and also the trailing zero are significant. The only digits here that are not significant are the leading zeros. It just like shows you how precise your measurement is, right? But they don't mean anything. They're not meaningful contributions. All the other zeros and non-zero digits, they are meaningful, okay, for your measurement. The last digit, okay, written down in the measurement, is the first digit with some uncertainty. So what does it mean? So this last digit here, or better, let's take an example of a ruler. We have an object and the measurement is like this, okay? You took the measurement and it looks like this. So if you see the scale of this ruler here, we could certainly say that this object is at least 15.4 centimeters, okay, centimeters. Let's imagine it's centimeters here, right? But you see that's actually in between the 4 and 5 in the scale, okay? So we can actually add a last digit for this measurement here. And this, we can assume that because it's, well, it's almost in the middle of 4 and 5, you can see it's 45 centimeters. So this last digit here is not certain, okay? But depending on the person who measures, it says that it's not exactly 15.4, but it's not also 15.5. So it means it carries some uncertainty, okay? And when you see a measurement, always the last digit is the uncertainty digit. Okay, now that you learned about all those concepts related with measurements in physics, let's put it to practice. So imagine we have a shooting competition, okay? And these are the results for 4 different shooters. And we want to analyze them in terms of accuracy and precision, okay? Let's start with this one top left here. And, well, we can see that the shots are all in the center and they're really close to each other. So it means the shooter has a high accuracy and high precision, right? That's because, well, high accuracy, they're all very close to the center, and high precision because all the 4 shots are very close to each other. Now let's go to the bottom left here. You can see that, well, the shots are really kind of close to the center compared to the other ones, right? But they are a little bit sparse. They're not very close to each other. So it means the shooter has a high accuracy. They're close to the center, but the shooter has a low precision because the shots are not very close to each other. If we go to this one, top right target, we see that the shots are not close to the center, but they are very close to each other. It means low accuracy, okay, far from the center, but high precision. 4 shots are very close. And the last one, I think that's the loser, right? Because all the shots are far from the center of the target and they are very sparse. So it has a low accuracy, far from the center, and low precision. The shots are not close to each other. Okay? I hope this example made things a little bit more clear. Okay? And I leave you with a question. So what's the relationship between the accuracy and uncertainty of a measurement? So think about this question and write your answers in the comment section.
Physics can be easy. Subscribe to our channel and learn with the geeks.